viewers, welcome back to my channel, and in this video we're going to solve an applied electricity trial question. We've solved previous videos on the same topic. Kindly go back and look at my videos by subscribing to this channel. So today we have this circuit here, which is a bridge circuit, and it's also an application of Thevenin's theorem. So let's see what the question is having for us. So determine the voltage across the terminal A and B, then find in ohm the resistance seen between the terminals A and B when the 6 volts is deactivated. So you can see from this circuit that we have terminal A and B, which is an open circuit, then have 4 resistors arranged this way. Now this is a bridge circuit, so let's see how you're going to solve this problem. Kindly watch this video to the end. So having this, I always prefer to make the bridge circuit in the square form, in the rhombus form than this way. So that will be, I'll have this, then something like this, then I'll come here like this, then similarly I'll draw it this way, then also this way. Then my terminals will come, my 6 volt terminal, here 6 volts, have my open here. So now I'm going to put VTH here, since you are looking for the voltage across A and B. Here will be my A, here will be my B, where I have here to be 2 ohm, here to be 4 ohm, here to be 2 ohm, as well as here as 4 ohm. So once I have this in this form, it becomes clearer and easier to solve. So let's see. Once you have this, you know that the current coming from the source is I. Let's locate it as I. And upon reaching here as a node, it was split into I1 and also I2. And the I1, upon reaching here, there is open circuit to move straight here. The I2 also join it and form I back again. So once you have this, you apply Kirchhoff's laws to find the values for I1 and I2. I'm going to take this loop, one, check it carefully, like this, as my first loop. So the total voltage in this loop is 6 volts and is equal to the voltage drop across here, which is 2 multiplied by I1, plus the voltage drop across here, which is also 4 multiplied by I1, and that is giving me 6 is equal to 6 I1. Therefore I1 is equal to 1 ampere. Now let me form another loop here, that is here, move up, then I'll come down. It's also a loop, a complete loop. My total voltage is 6 and the voltage drop here is 4I2 plus 2I2. The same current will pass through here, since no current will pass here. There is infinite resistance here, so that will be 2I2. So 6 will be equal to 6I2. Therefore I2 is equal to 1 ampere. Once I have this, I know my values for I1 and I2. Therefore my I is simply going to be 2 ampere, since KCL is saying that current reaching is the same as current leaving. So if the current leaving is 1 plus 1, current reaching also be 2. So therefore I come back to my question to find VTH. So in Thevenin's, we locate a direction for VTH. I've chosen this top direction. So once I choose here, I'm going to take this loop to find my VTH. So in this loop, I have this voltage and voltage drops here. So let's see, my VTH in that direction will be equal to, against this direction, because I1 is coming, so negative 2 multiplying I1, then this one is in the same direction, so plus 4I2, that is 4 multiplying I2, which is same as 4I2 minus 2I1. Where both currents is 1 ampere, this will be 4 minus 2 and is equal to 2 volts. So this gives the voltage between the terminals A and B. Now let's go to the second part. It said find in ohms the resistance seen between the terminals A and B when the 6 volts is deactivated. So at this point we still have to redraw. We are going to find the Thevenin's resistance. So redrawing Then after, we will deactivate the source. When the source is a voltage source, we create a short circuit. But if it is a current source, we then create an open circuit for it. In our problem, it is a voltage source. We are going to create a short circuit here, down here, also down here. We label our terminals. Here is A, here is B. Let me make here C, let me make here D. Where I have here 2 ohms, 4 ohms. I have 4 ohms here, then 2 ohms. So through this, I'm going to find my total resistance, which is called RTH, and RTH will be here, Thevenin's resistance. So that one will be in middle. So let's open up this. So let's see how we're going to do it. Bring this out, you get something like this, then also get something like this, sorry. So once you get something like this, let me clean it and bring it down here. So this will be the node. Let me make it this way. Then after, I'll label here as A and here as B. Now you can see that from A to D we have a resistor, so we will put this one up here, then have a resistor here and label here as D. Then we know that from D to B we have a resistor, we put another resistor here, then we come to B. Then from A to C we just put a resistor here and move to C, then from C finally to B. And after, we have our, this part is D to C. D to C is a short circuit. We put our short circuit here like this. From A to D we have 4 ohm. From A to C we have 2 ohm. From D to B we have 2 ohm. Then from C to B we have 4 ohm. So at this point I move straight to finding the value for the effective resistance here. So how do I get it? You can see that this 4 ohm and this 2 ohm are in parallel, because you can move through them without moving through any other element. Same applies to here. So I have 2 parallel connections, which is 4 ohm and 2 ohm. So my RT each will be equal to 4 ohm parallel to 2 ohm. That is for this part. Then also the same applies to, so once I combine them, I'll redraw my circuit back. So there is 2 of this, so let's find this will be 4 times 2 over 4 plus 2, and that is 8 over 6, which is equal to 4 over 3 ohm. So now redrawing this, I'm going to have this place back like this to my A, and I'll cross from here. It also move to another part, and it also have only one because I've combined the other part like this, simply like this. Where here will be 4 over 3, 4 over 3. They are now in series, therefore my RTH is simply 4 over 3 plus 4 over 3, and that will give me 8 over 3 simply. So what is 8 over 3? If you have 8 over 3, is the same as 2.67 ohms. Thank you for watching this video. Kindly subscribe to motivate me. Thanks for watching. Kindly like too.